What up, blood? Sufficient time has prolapsed in order to enable us to harden this epoxy on the cylinder for the DeWalt 60 volt cordless compressor. Cordless compressor, you ask, but pneumatic tools, they always got a cord. I don't ask too many questions. I just do as I'm told. As a married man, yeah, well, you believe that? I got a bridge port to sell you. We'll get this cleaned up. One of the things that come out of the discussion is this is, well, quite visibly not a very skookum design, and we see here there's no wrist pin. I didn't notice this at the first, but thank you very much for putting your countenance in the doobly-doo and pointing this out. There's no wrist pin on the cylinder here. There's also no thickness to it. So what that means is that this guy, because there's no wrist pin, it cannot stay parallel rather, to the bore of the cylinder. As it chooches around, it has to do one of these. As this offset spins around, so too spins around the conrod. That means that this is constantly weeble wobbling back and forth. If you think that's a good design decision, yeah, well, I got a compressor to sell you. In this case, though, I've closed up the hole, and this would allow for heat scavenging, just cooling, some scavenge air to cool it, but very likely also at the bottom dead center of the stroke, because the other part of this design, it does not unload. This, if you have 100 or 80 psi when you're doing the ka-chunk automation, this starts up loaded. So in order to unload that, they've put in a little valve here. Now, I don't begrudge anyone plausible deniability. Well, I am trying to be far less cynical, especially given the gravitas afforded by this ISO 1217. We are going to make sure that this 1.2 standard cubic feet per minute at 90 pissies is not a typo. The way we're going to do that is just one of these here flow meters. This has to be coupled in the correct direction, straight up and down, and then the friction from the flow moving past it pushes up this little weight, and we read off at the at the end of the skirt what the actual reading is in cubic feet per minute. And then we'll put a little needle valve on there just to keep the pressure up. For additional street cred, this will be on the final exam. Extra credits, extra jankiness. We got this set up, and I had to kind of prop this up to get this to make sure that we're plumb in all directions. As well, we got a gauge here and a needle valve. This will provide the resistance. The resistance to flow will help the pressure increase, because of course a compressor is a pump, and a pump only produces flow. It doesn't produce pressure. That's neither here nor... Oh, also another thing guys always ask me, why are there bubbles in the gauges? It's on account of glycerin. These are glycerin filled gauges, or this was formerly glycerin filled, but it all leaked up everywhere, probably was stored upside down. That glycerin is a shock absorber, so it helps the needle not bounce around so much. Normally, we get this all back together prior to testing. However, we ain't normal. We're going to run this twice in two different configurations. One with the bubble gum in the hole, one without the bubble gum in the hole. You'll note no safety at all on her. We are not reading the pressure for the ka-chunk switch to turn off and on the brushless DC motor. So this pressure switch gets fed back into the confuser turns off. So there's no safety. So that means I got to be the safety. I'm going to read that gauge when it gets to about 100. I will turn it off manually. Now, worst comes to worst, of course, I can just pull the battery out. I'll just get that moving a little bit before we do it electrically. Make sure she's not cocked over. Eliminate any sticktivity. And it has got a nice little whistle to her. Key intact. Whoa. She moves pretty good. Yeah, got a whiff of hair in there. You can smell something's getting hot, and we are at exactly 100 psi on the gauge. Now we'll open the valve and run the compressor till we get 90 psi steady on this guy. And then we'll read how much flow is coming through that flow meter. It's not reading on the scale. I had her set up so the gauge was at 90 psi steady, and we couldn't get that little baculum even to register on the scale. So now what I'm going to do, I'm going to do the obverse. I'm going to set her at 1.2. That's the first bar past 1, and then we'll see if she maintains pressure. Should maintain 90 psi according to the nameplate. Okay, we saw there we couldn't maintain 0.8 CFM at 90 psi. It was dropping. Am I missing something here? Why is it that whatever they're rated at, I can't seem to get the same results here in my own shop? Is it because I don't have all the fancy instruments? That's got to be it, right? I got a fresh battery. We're going to see if there's any discernible difference now with that plug of bubble gum out. That's not good. All right, at 40 psi, we're steady state at 0.8 CFM. That's being generous as well. And start the stopwatch. I got a big bastard 9 ampere hour, brand new, charged it. We're going to see how long she runs for at 90 psi. Startled me. 33 minutes and 27 seconds. Wow, we'll say 32 minutes she ran. Now that makes about sense because 20 volts times 9 ampere hours is 180 volts ampere hours divided by 60. That's 3. 3 divided by the 4.5 amps that we were running at. Ooh, that's hot. 4.5 amps we were running at gives us what? 0.66 of an hour times 60. That's 40 minutes run time. We're pretty close there. Plus minus the allowable. Now this is nuts. This is nuts. I've been thinking about this. The cost of operating this thing per kilowatt hour. You look at a plug-in unit versus this. I mean, it's going to be a factor of 10, easily a factor of 10 more expensive to run this. That's without the additional cost of the battery-powered compressor. The cost to run this thing is just exorbitant. So if you don't have a usage case for this particular, you don't have to have a battery-powered one or have a gasoline-powered one. This one is going to be the most expensive per watt used of any tool. It'll probably be, this is conjecture mine, it'll probably be a factor of 10 Not to mention that I'm told, I haven't confirmed this, but I'm told that these are some of the worst batteries in the industry, not because the cells are cheap or they're poorly constructed. It's the design itself. When you go from 60 volts to the 20 volts, they're all seriesed up. So when you run these hot and hard, there's going to be inherent differences in some of the chemistries and the construction. There's a tolerance there. So the voltages are going to be slightly different with all, how many are these, 20 or so cells in here? And they're all in series to get that 60 volts. Then when you pull it out of the tool, they all go back to parallel. There's a mechanical switch in there, parallels them up, stick them on the charger. Now all of a sudden you have all these unbalanced cells, and the cells that have a little higher voltage are going to dump as much current as they possibly can into the cells that have fewer, a little bit less voltage. So I am told, and it makes sense to me, we're going to save that for another time to see if we can cook some of these batteries in that failure mode. I think this is an interesting point to touch on here. The cost for running these things per kilowatt hour, I mean, for batteries, just exorbitant. And you wonder why they're pushing battery powered tools so much. It's because they make so much Jesus money off the things. 200 Kanaki stand Copex, likely. You know, you factor in the tax, and that's a cost for me as well as for you. So let's look at this here. We'll do a little mental mathematics. We got 60 volts, 4.5 amps. That gives us, we'll do 4 amps. So that gives us 140 watts. Now it's running at 0.66 of an hour, 40 minutes. We'll give it a little helping hand there. That gives us 160, 66 times, that's 160 watt hours. Okay, so each charge gives us 160 watt hours, not kilowatt hours. Finger, how many times can you charge this before she give up to ghost? Let's assume 100. So that's 160 times 100, that's 16,000. That gives us 16 kilowatt hours. 16 kilowatt hours we get out of that. She cost us 200. 200 divided by 16, that's 12 and a half doll hairs per kilowatt hour. When you plug yourself into the Pixie receptacle there, light your teeth on fire, how much that cost you? But 12 kilowatt hours. We got cheap electricity here in Canada. Even if it's 25 cents per kilowatt hour, I mean, the difference, it just, this thing, unless you got a special usage case for this, and looking at this, is she going to last? She ain't too skookum, quite frankly. She ain't going to last that long. So unless you got a very special usage case, there ain't no fucking point in buying one of these, because you're just throwing money, right? It's like digging a hole in the ocean and trying to fill it with money. Couple that with the fact that the chooch factor on the outlet, I can't get anywhere even close to what they're calling for on the ratings. I think that must be a typo. Instead of 1.5, it should likely be farting a windstorm. There you have it. Ain't no fucking good at all. Thanks for watching. Keep your dick in a vice.